Let's solve the climbing stairs problem on LeetCode. In this problem, you're climbing a staircase. It takes n steps to reach the top. However, we can either climb the staircase either 1 or 2 steps at a time. And we need to find in how many distinct ways we can climb to the top. So for example, if we had a staircase n is equal to 2, so there are 2 steps, there are 2 ways to reach the top. We can either take 2 individual steps or just take 2 steps straight away, so we need to return 2. In example 2, input n is equal to 3, so there are 3 ways to reach the top. We could either take 3 individual steps, or take 1 step and then 2 steps, or take 2 steps and then 1 step. So there are 3 ways to reach the top. So there are 2 ways to solve this problem. We could solve it recursively and iteratively. I'm going to solve it recursively because I want to introduce the concept of memoization, which is when we create a cache array which stores calculated values of recursive calls. We'll take a look more into what that is and what that looks like as we progress through the code, but as for now, let's just begin. So within our public int climb stairs, all we're going to do is return the result of the recursive method which we're going to create that takes the number of staircases given to us. So now we actually have to create our helper function climb. So what's it going to return? Int. We called it climb, and it takes int n as its input or signature. Now, since this is recursion, we need a base case, and we need to call the method in itself. So actually, before we do that, I want to go through a couple examples and see what exactly we're doing. So for example, if they gave us staircase or n is equal to 1, so there's just 1 step, there's just one way to go to the top, and that's just by taking 1 step. If they gave us n equals to 2, or in other words, 2 steps, there are 2 ways to approach the top. We could either take 2 individual steps, or we can just take 2 steps directly. For n equals to 3, there are 3 ways to reach the top. You can either take 3 individual steps, take 2 steps first and then 1 step, or take 1 step and then 2 steps. Now for n equals to 4 is where it gets interesting, because up to this point, all we need to return is n itself. So for values less than or equal to 3, we're just returning n. And if you notice, that's going to be our base case. But now let's take a look at 4. So for n equals to 4, there are actually 5 ways to reach the top, which are the following. We can take 4 individual steps. We could take 2 individual steps and then 2 steps. Or we could take 1 individual step, then 2 steps, then 1 step. Or we could take 2 steps and then 1 step and then 1 step. Or we could take 2 steps and then 2 steps. For n equals to 5, we could take 5 individual steps. Or we could take 1 individual step, and then another individual step, and then another individual step, and then 2 steps. Or we could take 1 step, 1 step, 2 step, 1 step. Or we could take 1 step, 2 step, 1 step, 1 step. Or we could take 2, 1, 1, 1. Or we could take 2 steps, 2 steps, and then 1 step. Similarly, we could take 2 steps, 1 step, 2. Or we could take 1, 2, or 2. And that would be 1, 2, 3, 4, 5, 6, 7, 8 ways to approach the top. So let's try to find a pattern here. Like I said, for values of n less than or equal to 3, all we need to return is n. So there are n ways to approach the top for values of n less than or equal to 3. For n equals to 4 and n equals to 5, we notice that when staircase is equal to 4, there are 5 ways to reach the top. And for n equals to 5, there are 8 ways to reach the top. So this is actually what our list looks like as we increase n. So for n equals to 1, for 1 staircase, there is 1 way to reach the top. For n equals to 2, there are 2 ways to reach the top. N equals to 3, there's 3 ways to reach the top. N equals to 4, there are 5 ways to reach the top. And finally, for n equals to 5, there are 8 ways to reach the top. If you keep going with n, so n equals to 6, n equals to 7, etc., you're going to see for n equals to 6, there are 13 ways to reach the top. For n equals to 7, there are 21 ways to reach the top, and so on and so forth. So actually what this looks like is the Fibonacci sequence. And we know how to solve the Fibonacci sequence recursively. It's just Fibonacci at n is equal to Fibonacci at n minus 1 plus Fibonacci at n minus 2. Now, to make this make sense, if we take a look at n equals to 4, it's actually going to take us the number of ways to reach the staircase when it's equal to 3 plus the number of ways to reach the staircase when n equals to 2. And if we look at n equals to 5, since there are 8 ways to reach the top, this is also the same as saying there are n ways, or there are 5 ways to reach the top when n is equal to 4, plus when n is equal to 3, there are 3 ways to reach the top. So 3 plus 5, that's 8. And for n equals to 4, 3 plus 2, that's 5. So this equation makes sense. So let's go ahead and begin coding now. First, we need our base case. So if n is less than or equal to 3, then we just need to return n. And now for our recursive statement, we need to return climb at n minus 1 plus climb at n minus 2. So let's submit our code and see if it works. As you can see, time limit exceeded at n equals to 40. That's because what's happening is, as our input n increases, the time it takes for the recursive call to be calculated and return results exponentially increases. And that's because if we, for example, were trying to find climb 5, this would be us saying find climb at 4 plus climb at 3. And then we need to find climb at 4, which is climb at 3 plus climb at 2. If you notice, when we do climb at 5, we're retrieving climb at 4 plus climb at 3. And then once we find climb at 4, we're finding climb at 3 again. And this is greatly hindering our compilation time. And as n grows, the number of calls which we calculate once and then we need to calculate again increases. Now this is just a simple example, but if we had to do climb 8, for example, we'd have to do climb 7 plus climb 6. And then to find climb 7, we'd have to do climb 6 plus climb 5. But we already need to calculate climb 6. And all these constant calling of recursive functions of values that we already found is causing our compilation time, or the time that it takes to find the final result, to drastically increase, or increase exponentially actually, which caused us to receive this message, time limit exceeded. So the way we're going to solve this is through memoization. We're going to create an array called cache, and every time we perform a recursive call and find the result. So for example, if we were to find climb 5, we'd have to do climb 4 plus climb 3, and to find climb 4, we'd have to do climb 3 plus climb 2. Instead of recalculating this, what we're going to do is we're going to store the result of this into a cache array. So by the time this method is called again, climb at 3, we already have this value in our cache, and we just need to retrieve it, and there's no need to perform any more recursive calls. So for example, if we had to find climb at 9, which is just climb at 8 plus climb at 7, and then obviously climb at 8 is equal to climb climb at 7 plus climb at 6, so on and so forth. Once we find climb at 7, we just store it into a cache. Therefore, anytime we need to call this method again with this specific input, we just retrieve it from the cache array which we created, and that basically fixes our time limit exceeded problem. So had we not done memoization, our time complexity would be O2 to the power of n, and after memoization it's just On. So to perform memoization, first we're going to create an array of integers, and we can just call that climbing stairs cache. Now we have to instantiate climbing stairs cache and input the size that it's going to be, and the size that it's going to be is n plus 1, because we want to store results from 0 all the way up to n. So climbing stairs cache is equal to new int, which takes n plus 1. And then I'm gonna fix our base case a little just so that it makes more sense. So now we're going to check if the step that we're on was already calculated and placed into the climbing stairs cache, and if that's the case, then just retrieve the result of it. So return the result of climbing stairs cache at n. Here we should include the cache. Otherwise, what we're going to do is the recursive call, but we're going to store it in an int result. So climb n minus 1 minus climb at n minus 2. Then for the given step that we're on, so climbing stairs cache at n, we're going to input our result into our cache array. And then finally, we just need to return result. So let's submit our code now and see if it works. I put a minus here instead of a plus. There we go. So that was the climbing stair problems on LeetCode. I hope you found that video helpful and you understood the concept of memoization. And thanks for watching.